Today's daily, November 5th, 2024. 2914, minimum number of changes to make binary string beautiful. You are given a zero-index binary string having an even length. A string is beautiful if it's possible to partition it into one or more substrings such that each substring has an even length and each substring only contains ones or only zeros. You can change any character in S to 0 or 1. Okay, return the minimum number of changes to make the string beautiful. All right. That's a funky one. Okay, so it has an even length, because I was going to say if it's an odd length, then there's no way to split it into a bunch of strings of even length. Is this like a sliding window problem? This feels like a sliding window problem. String. It's just called string. Okay. Interesting. I think we want to get all the characters. Let's see. Okay. Okay, so my first thought is that if you work in from the ends, let's say we have something like this. Whatever the end is, you might as well make the next one the same thing. It doesn't matter if, there's a 1 after it, and then now you have to change that to a 0, because either the one after that would already have a 1, or it would be a 0, and if you change this to a 1, then you either take this chunk of 2 and have this uneven string, or okay, yeah, that's the first thing I recognize is that the ends determine all. So I think you work in from the ends. Okay, yeah, that's what I'm thinking. Is that if any pairs at the ends are different, they may as well be whatever value is at the end. Because, it doesn't matter if these guys are all the same. This guy still needs a buddy over here. And that guy needs a buddy. And the only way that he could get that buddy is from here. So you could just work in terms of pairs. Work in pairs. Okay, this is just a long shot, but if I say for I in range 0 to length of string, and we go, we take steps of 2. Is it possible to say changes equals 0, and we'll just say if si does not equal si plus 1, changes plus equals 1. And then just return changes. That's, whoa. Okay, wait, how do I, okay. Does that work for everything? So yeah, that's why I was thinking that, is that it's just a matter of you just work in pairs. And you say, okay, because you might as well work in pairs. Because it doesn't matter if it's like bang, 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 like that. That's still a beautiful string. The partitions doesn't cost anything. It's only a matter of, is it askew? Like this right here, how many changes does this take? Even though they're in pairs, this 0 over here has to be, it's like, okay, well, we could set this one to be, this 1 to be a 1, because then it's matching. But then, this is just a string of odd length. So now we need to, so that's not going to help us, and there's going to be 1 left over. So I wonder if that will work for everything. I have a feeling that it won't. Nope, it does. Wow. Okay, so that's a good problem. It really makes you just think about the parameters of the problem, but that's the core of it, is that you have to be able to, like, even though this looks like it's really close, it is 1, 2, 3, 4 changes away. Because, okay, well, these zeros are left alone, and they're uneven string lengths, so you change those to 1s. But then these ones don't really, this doesn't really help you at all. Even though they look like they're the same, they're still odd string lengths. So you could change that and so on. So if you just work in pairs, then you're ensuring that you keep that pattern correct, and you're only, each string length is even. Anyway, I really feel like that one's hard to express out loud, but I got the solution. I'm pretty happy with that.